is the exponential, I'm sorry, linear versus exponential review for your OST test. Here we have a linear general form. Here we have an exponential general form. The m in our linear equation is the slope. B is the rate. Whew. B is the rate that is changing our exponential function. Over here, B is the y-intercept or the starting point. And then over here, A is the y-intercept or starting point for our exponential function. All right, number 1 says the relationship between the distance driven and total cost when a taxi driver charges $2.50 for the first mile and $1.50 for each additional mile. So you want to think about what is going to happen over and over again here. When we see the word additional, okay, that means that we're going to add $1.50 every time they drive another mile during this particular taxi service. So we know that since we're adding, this is going to be a linear function. We're going to have the general form of y equals mx plus b. So when we have something that happens over and over and over again, that is our slope. Okay, that is a repeated value. So the $1.50 is going to repeat. And then the $2.50 is only charged one time. Okay. So that's our y-intercept. So our function would be y equals 1.50x plus 2.50. Number 2, the relationship between the number of bacteria and time when a culture of 6,000 bacteria is reduced by 50% every day. So whenever we see any type of multiplication or we see a percent, it is an exponential function. This is our general form for an exponential. When we throw in a percent, we take that b value, okay, and we change it to be 1 plus or 1 minus our percent. So in this case, we are going to use this particular function. We have to decide if it is plus or minus based on what we're given. Since they use the word reduced by 50%, that tells us it's going to be decreasing. So our general function is going to be 1 minus our percent. Minus is associated with a reduction, a decrease, or a decay. Addition in the middle is associated with growth. So here, A is going to be our y-intercept or initial value. P is going to be our percent as a decimal. X would be time, but we're not solving here. So our y-intercept, or what the starting number is that 6,000 bacteria. That's our starting point, so that's going to be our A value. And then 50%, this is our P, but we need to change it over to be a decimal, and that's 0.50. Move that decimal 2 to the left. So when I say that, I mean if we have 50, we know that we can write 50 like that, move it 2 to the left, and we have 0.50 for our P value. So our function, do a different color here, is going to be y equals 6,000 and then 1 minus 0.50 to the power of x. We could simplify that if we wanted to. And in the middle, we would do 1 minus 0.50, which is 0.50 to x. It doesn't matter which way you write that. Number 3, the relationship between the altitude of a hot air balloon and time when the hot air balloon takes off at 5,500 feet above sea level and it rises 120 feet every minute. So this is kind of like number 1, where we're going to be adding something every single time something happens. So the fact that we have addition tells us that we're going to have that linear function. Okay, we have to decide what's our slope and what's our y-intercept. Remember, the slope or m is going to happen over and over and over again. So in this case, that's going to be that 120 feet that happens every minute. And then the initial takes off at 5,550. So that's going to be our one-time value or y-intercept. Marcel rented a moving truck for the day. The rental company charges $40 per day and 50 cents per mile. How much would it cost to rent this truck if he drove 220 miles? So we're going to assume that this equation is for 1 day only. 1 day only. So if we assume it's for 1 day only, he's going to be charged $40 for that 1 day plus 50 cents every time he goes another mile. So since we're adding something every single time, again, that's linear. If we see addition or we know it's addition, it's going to be linear. So I want you to think, write down, what is that M value? What's happening over and over and over again? Hopefully, you're thinking 50 cents, because that 50 cents is per mile. So we have y equals 0.50x plus the $40 that happens one time. 40 is our y-intercept or our starting point. Because we're going to be charged $40 no matter how many miles we drove. Now, if we want to know how many miles, if we want to know how much it costs for him to drive 220 miles, well, we know x must be the number of miles driven, because we're doing 50 cents per mile, and then y has to be the cost. So we're going to take our function and plug in 220 for the number of miles, and we're going to pull up our calculator. You can do this on Desmos as well if you can use Desmos as a calculator. Oops. Sorry about that. Okay. Calculator does not seem to be working. Give me a second, group. Okay, I guess we'll use Desmos. So right there, you can see our answer is 150. So that means it will cost $150 if Marcel drives 220 miles. Number 5, you are studying a population of fish in a lake. At the beginning of your study, you find that the lake has 1,000 fish. And the population doubles every year. How many fish are in the lake after 6 years? First, we need to decide what type of function we have. If we see the word doubles, that implies that something is multiplying by 2. Doubling is multiplying by 2. So since we're multiplying, we'll be using the exponential function. And here's our general form. We don't need the other form because we don't have a percent. So this will be a great form for us. A is going to be our y-intercept or starting point, and B is going to be our rate that we are multiplying by. So our starting point is that 1,000 fish. So we'll start with 1,000 fish. And then if it's doubling every year, doubling implies that we're multiplying by 2. So 2 is our rate or our b value, and then we have a power of x. And for that, we will plug in 6 because we want to know how many fish are in the lake after 6 years. We can use Desmos to help us out. see here, our final answer is 64,000. 64,000. You have to go back to context. What were we looking for? We started with 1,000 fish. We want to know how many fish are in this particular lake after 6 years, and that would be 64,000 fish. All right, number 6, it says the data in the table shows the cost of renting a bicycle by the hour, including a deposit. If hours H were graphed on the horizontal axis and cost C were graphed on the vertical axis, what would be the equation of a line that fits our data? So I think the easiest way to do this problem is to just plug everything into Desmos. We could definitely do this by hand and try to work it out, but when it comes to things like this, and we may have different ways of thinking about it, Desmos will not fail us here. So what I'm going to do is put each of these coordinate points, so 215 is a coordinate point, 510 is a coordinate point, and 845 is a coordinate point. So I put those in, and then I'm going to type in each of my equations, but I do have to transfer these over to y and x instead of c and h. So I'll type in each equation, oh, I did not put my points in right. 215, 530. There we go. Okay, let's make Desmos a little bit bigger here. We can zoom in and out. Okay, so if you look here, you can see the blue line is going through all 3 points. So let's turn off the other ones. And our blue line is the 5x plus 5. So if we transfer that over here, 5x plus 5 is the same as letter C. Number 7, which scenario represents exponential growth? So when we see exponential, we want to think multiplication or percent, okay, either one. So number 1, a water tank is filled at a rate of 2 gallons per minute. So if you think about how we add water to a tank, that would be adding to every single minute. So that's going to be addition. So 1 is not our answer. Number 2, a vine grows 6 inches every week. So you have to think about, are you multiplying by 6 or are you adding 6 inches every single week? And when a flower grows or a vine grows, we're adding 6. Number 3, a species of fly doubles its population every month during the summer. That looks pretty good for the sole fact of the word doubles. That implies that we are multiplying by 2. So we're gonna hang on to number 3 for a second. Number 4, a car increases its distance from a garage as it travels at a constant speed of 25 miles per hour. So if it's a constant speed, we know that that is a linear function because linear functions are the only functions that have constant slope or a slope that never changes. So we're not going to choose 4 because 4 is linear. So 3 is the exponential growth function for this one. Milton has his money invested in a stock portfolio. The value of his portfolio can be modeled by the function where X is the number of years since he made his investment. Which statement describes the rate of change of the value of his portfolio? So if we break this down, what does this 30,000 mean? That means that's his initial investment. And then this 0.78 tells us 2 things. The first thing that it tells us is that this is a decaying or decreasing function. And we can figure out what it's decreasing by when we look at its distance from 1. Okay, so if we do 1 minus 0.78, we would end up with 0.22. So what's happening here is that we are losing 22% of the investment, or Milton is losing 22% of his investment every single year. So our answer would be number 2. Don't be deceived by these because number 1 looks pretty good. We know it's decreasing and we see that 0.78, but you have to think about percent change being your distance from 1. Okay, you're going to go ahead and try these on your own. So you can go ahead and pause the video and work these out. I'm going to go ahead and put the answers up here for you so that you can check your work. Okay, so an explanation of this one is that the 1225 is per month plus a one-time fee of $35.50 to join. So that's why that's our y-intercept. Explanation on this one, there's 281 girls to start. That's our y-intercept. And then we're losing 2% each year. So when we lose 2%, we have to put in that 1 minus because it's a percent. And then 2% written as a decimal is 0.02. Here for number 11 is that we have 12,480 as the population, and then that word doubles implies multiplication, which is an exponential. So that's our rate of 2 right here, and then obviously our power of x. This is definitely linear because we're losing the same amount every single hour. But why is that 2 negative? Why are we doing a -2? Well, since we're losing heat, then we would subtract 2 degrees every single hour. We started with 73, which was our y-intercept. If it's easier for you to think about it this way, you can think about it as we started at 73 degrees and then we lost 2 per hour. That's definitely an okay way to write that particular function. All right, now go ahead and head on to Canvas and do your quiz, linear versus exponential for today.